Good afternoon, everybody. This is Jack Long, the Mad Scientist, and today we're going to be discussing a vertical panel saw in which the battens to support the panel are not routinely shifting. So when they plunge the saw in, they hear an audible banging noise as the battens are shifting, and this is causing them to go in and cut their battens as they're doing their rip cuts. So we're going to go in, evaluate the saw, find the missing parts, and in this particular case, we're going to fabricate some parts and then get them installed in the machine and get the customer back up and running until the replacement battens can be ordered and installed. So with that being said, let's jump into it. Alright, so first problem we have with this machine, when they lay the saw over to do rips, it cuts into the battens. So the Strebeeks, Elcons, Holzhers, this happens to be a Holzher, they will use a similar system where it's got a little reference point that sticks out, and then the saw comes down and lands on that, and that will send a reference mechanical typically and shift the battens up and down so they stay in line with the saw. And what happens is over time is these tend to get worn out, and this little lip right here will start to round over, or the mating surface that's up here will start to wear out. Now in this particular one, it's all mechanical, goes up over top of it, and there's a guide rail that shoves this down. Depending on the brand of machine that whoever it is that built it, some of them are electronic, well they'll use a sensor to see this and then it does it pneumatically, but this one here is 100% mechanical. So what we can see in this, we go in and we take a look at this, is the first thing I see is this outside here and outside here is worn, and so what will happen is that the unit will skip over this. The little tooth that comes out and catches this, it will skip. So what they're notorious for is for rounding the face of this, and if that happens, you go into the file and you just got to file that off to make it square. The other thing that happens is the plate that's up here, it will also round over. So the particular problem with this one, if you haven't noticed it by now, because I've showed you twice already, is that this plate is physically missing. So what we need to do is we need to put a new part in there, because what it's doing is these two little bitty forks that's on this, the squaring tubes, are hitting the outsides of this and they're not actually catching the center. So the customer does not have that part, so it's going to be a fabrication day. I'm going to run out and grab some supplies out of the truck and fabricate up a little part for that. Then we'll get that, we'll get it heated up, hardened, and go from there. Alright, so the object that we need to measure is this right here. You can see that? Right here. It's a little tough to get into, a little tough to measure where you can see it. I had to move it down to the other end of the machine. We have a little access to it. Let's see what we can find. Width. .6. I think you can see that. Oh, excuse me, 12.16. Depth front to back. It's about the same. This is the part where we kind of take an educated guess. Come on, get in there. 13. So 12 by 13. What we're going to do is we're going to make this into a rectangle. And then we're going to back bevel this side and this side, so as that unit starts to age, it gets a little bit of roll on the edge, and we can take it and flip it 180 degrees and use the other side. Alright, then we're going to countersink it so that it only goes on one way. Then we're going to harden it. Alright, so I've got my piece of steel here. I already sprayed it with the dye. It's drying now. So I'm going to gather my tools up and head up to the area where they have a vise and we can get everything laid out. Grab my drills. Yeah, I think we're ready to go. Alright, so the first thing we did was I measured this the width-wise, and this piece of steel is 12.5 millimeters wide. I need 12. Which doesn't surprise me. It's actually a little undersized when I sliced it. The first thing I'm going to do though is I'm going to square it up, square up my ends, and actually I'm going to leave it like it is because it's not too bad. So from there we want to scribe off our maker's marks as soon as I find my calipers. What would I do with them? There they are. I already had them out. Alright, so what we're going to have is, this is 12.5, which is 6.25. See if I can get you better in the screen. There we go. 6.25. Now I'm not too worried about hitting my exact center. So I'm going to set this for 6. Doesn't really matter. And I'm going to scratch it. You can see my little scratch lines in there. If I catch it just right, I can see them if you can't. And then set one for 7. So between those two scratch lines, as long as I hit between those two scratch lines with my center punch along this 7 millimeter square point that I have there, I know that I'll hit the center of that part. Now I'll cut this out to 14. Come on, get up there. 14, 13, 7, 13, 8, 13, 9, 14. Alright, so there's my part. This whole great big piece, and I'm going to use that. Alright, so the next thing we're going to do, we're going to go over here in the dark. We're going to dress this up, make it 12 millimeters. I'm not going to take it all off on one side. I'll measure it. 12.2, 12.4. I need a little more off the end. Make it this way. 12.1, 12.2, 12.2, 12.2. Alright, now the reason I'm taking it off one side and then go to the other side is because I've already marked my center. Probably should have taken it down to its finished width first, but you know, live and learn. 11.7, right at 12, right at 12, a little wide. 11.9. Alright, so we're most of the way there, guys. A little under, a little over. I'm going to take that.
Oh, I'm always dropping something. Now I find my center. Missed. Getting closer. Getting closer. A little more. Alright, so if you've ever used one of these self-aligning punches, they're great. You don't have to swing a hammer. But if you're off center just a little bit, then what you do is you take your point and you drive your point sideways until you get it to where you want it to be at. And I've got my chicken scratches. I don't know if you can see them. It's kind of hard to get that on camera, but I can see it here. So from here, what I'm going to do is chuck up a drill bit. We'll drill those holes out, counterbore it, then go from there.
Better.
These bits are not the best, but I needed something when I was out in the field. I'm constantly destroying my bits, so I don't spend a lot of money on them. Get this to support this a little bit, and we'll do it the hard way. Alright, so there we go. So we can get that a little bit more into the screen. A little deeper. That, like it's supposed to be there. Alright, so the last thing we need to do is separate this off. And then we'll put our back bevels on this and be done. Alright, now go grab a pair of pliers. $14 is our goal. $14, a little over 14. Now let's put our little back grind on it. All this back grind is doing, making sure that when it makes contact that it's doing with this front edge. That's all we're wanting to do with this. Alright. Polish this up a little bit, get rid of our burrs. That's it. The only thing left to do is harden it. So let's get us out some oil, and we'll heat it up over here, and then we'll drop it in the oil. Alright, so we got some oil here in a metal bucket. I'll warm this up. What I want to do is, I don't want to make it blue. So when we heat it up, I want to be somewhere in the dark brown. Here you can see it start to change color there. Then quench it. That's it. She's hard. If I had a choice, I would use dirty motor oil. Something like that's got a lot of carbon in it. But I don't have any, so I had to use some new motor oil. It's alright. It's hard anyway. That's it. We're ready to put her in. Alright, back at the machine. So let's see. Let me get me some Loctite here in just a second. I'm going to try our pieces here, see if they fit. Hide my trash bag. Well, that sucks. Come out there. Blue, 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 blue. Blue, 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 blue. All right. Let's get you up here where you can be seen. Let's make sure she fits first. Ah, like it belongs there. Holy cow. You guys caught it. So one of the statements made to me from customer is that they have replaced this part a couple times and it keeps coming loose. So I'll put a little bit of blue Loctite on it, and because it's a flathead screw, because this is a flathead screw, what I've done is I've put it up here closer to the head versus down at the end of it, so when it locks, it's only going to lock out here on the ends of the threads, so that as I'm screwing it in, that I don't seize up the entire length of the threads, because then it'll be too much. So I just put me a little bit, very, very little bit on the outside end. And I'm probably going to block you here where you can't see. Shooby-dooby-doop-doo-doo. Get that up there. And just like that. Put a little light on it now. Hey, you can see its action here. And as it comes down, catches. See what that's catching right there? Just like that. Alright, so now back to the initial problem, which up inside here, you can see that shaft. I can't hold the light and the camera right there. We need to lubricate that. So that is what allows this to float up and down. And like I said, it's better than it was. But what we need to do is get up there. We need to clean it first. We'll hit it with some solvent to get that debris and stuff off of it. And then we will shoot some white lithium grease up in it. Get her lubricated. Alright, I don't know if you can see it or not because I can't hold the camera, shoot it, and put the camera where I want it to be at without maybe getting the solvent on my camera lens. And I'd just as soon not melt my camera lens. Oh yeah, she's moving much better now. Can you see that? I don't know if you can or not. Whoop, where'd it go? There, let's try that. Can you see that now? And that was just solvent. That wasn't even lubricant. Get all this all nice and cleaned up. Don't want to do too much because it's
It is brake cleaner and it will eat paint. Bottom shaft. Oh yeah, much better. All right, so we're going to give that a few minutes to flash off. Then we'll come in here and hit it with some white lithium. Cycle it around a few times. All right, so that appears to have done it. So if you remember before, when this fork was bent out, it was getting it about right in here somewhere and would not go the rest of the way across. So when they would flip this head across and they'd lay it down into the gripping position, the shroud was hitting this, and you can see on the side of this, it's dinged up pretty good. And then when it would not be in the correct position, couldn't move, this roller, every time they plunge it in, would bend this bracket. Now, if memory serves me right, the older Holzhers had a different system, and I want to say it was a couple linkages. I may be misconstruing that with Strebies, perhaps. I had a brain fart there. But you can see now, when I push this, jumps completely out of the way. So that's what we want. Right now it's up in the waiting position for this roller. As soon as we flip that over, then it should plunge in, and you should see if it's in a position it needs to be in, these grids will move. Okay. What I'm going to do is put you out on a tripod, flip it over, and we'll see where it goes. All right, well, it seems to be working. Looks like I'm struggling a little bit there, but most of it was trying to find a spot that could actually catch it. You can see, goes in there, catches, pushes down. All right, so we're gonna call that one done. I did notice when I did this one that it skipped off of it, so I am going to take a file and I'm going to hit that edge there a little bit with a file, kind of square it up a little bit, but other than that, I think we're going to leave it like it is.